After we explore the geometry of linear algebra, it is time for yet another point of view, the programming one. If you want to get into data science, that's going to be the context in which you will need linear algebra. So, let's open a Jupyter notebook and see how we can code a matrix, a vector, and a scalar. The simplest and most flexible way to work with scalars, vectors, and matrices in Python is by using arrays. Moreover, we'll use the NumPy functionalities as they are optimized for such operations. I'll import NumPy as NP. Okay, let's start by declaring a scalar. In Python and many other languages, an integer or a float are doing the job. So, s equals 5 will do. Time for something more sophisticated. How would we declare a vector? Say we are looking at the same vector as before, 5 minus 2 and 4. Let's declare a new variable v equal to np array of 5 minus 2 and 4. Note that there are round brackets for the np array method and square brackets for the vector itself. Printing v, we would see that it contains the 3 values we wanted. Cool, we have created a vector. By default, v is a row vector. All right. Finally, let's create a matrix. M equals np array of round brackets. Now, if you think about it, this matrix actually contains 2 vectors, this one and that one. In fact, that is how we would go about declaring it. Square brackets, 5, 12, 6, close the brackets, comma. Square brackets, minus 3, 0, 14, close all brackets. Here. As you can see, we have a matrix, exactly as we wanted. These tasks are quite simple, but please feel free to practice later on. However, there are several important programming considerations we need to make. We will focus on them now as they are paramount for coding. First, data types. If we write type, brackets, and then a variable, we would obtain the data type of that variable. Type s. So, s is int, or an integer. V and M are ND arrays. ND array stands for an n-dimensional array. More specifically, the vector v is a one-dimensional array, while the matrix M is a two-dimensional array. In general, we can have n-dimensional arrays, which we will talk about later on. All right. Finally, if I want s to be consistent with the others, I can actually declare it as an array too. s underscore array equals np array of 5. Checking its data type again, we will see it is an ND array. And that's another way you can create a scalar in Python. For all practical purposes, in Python and within NumPy, integers or floats and arrays with one element behave in the same way regarding linear algebraic operations. All right. What about the shapes of the variables? There is a method called shape, which we can apply to our objects to check their dimensionality or shape. m.shape returns 2 by 3. And that's also the expected result, as we are dealing with a 2 by 3 matrix. v.shape returns 3, comma. This is something which you are likely to see in some programming languages, but not all. It is basically indicating that in the memory of the computer, this object has 3 elements. The elements are stored in order, though. Depending on our needs, we could use the reshape method to create a row or a column vector. v.reshape and the form we want. There are 2 possibilities, 1, 3, and 3, 1. The first gives us a row vector, the second, a column one. Okay. Finally, we can check the shape of S. We get an error, as int objects don't have shape. Trying the same method on S array, we simply have parentheses. That's because a scalar is a zero-dimensional object, thus it has no shape, precisely like the point we discussed in the previous lesson. Cool! That's more or less how we can declare and think about matrices, vectors, and scalars in Python. In the next lectures, we will explore new concepts and practice them with code. Thanks for watching.